In video 3 for Unit 8, we are going to be using our graphing calculator. Please make sure you have that out now. If you don't have it out, press pause, go get it, and then restart the video or pick up from where you left off. Okay, so to start with our notes right now, what we have to do is recall a couple things about functions. First, a function f of x is equal to 0 when f of x is equal to 0, or y equals 0. At any x-intercept, which is where the graph crosses the x-axis. With all of that said, how many zeros does this graph have? Well, here's my x-axis. The graph crosses it 1, 2, 3 times. I have 3 zeros. What are the zeros? They're at -4, 0, -1, 0, and at 1, 0. 3 solutions, 3 zeros. Those are my 3 ordered pairs. Now, as you can see in the next line, often but not always, the number of zeros that a function has matches exactly with the largest exponent term in its equation. What does that mean? Here's my function rule, or my equation. The largest exponent in that equation is 2. Here's my graph. Here's my x-axis. The graph intercepts or crosses the x-axis twice. I have 2 zeros, 2 solutions. Those numbers match exactly. In my next example, I have a 3, a 2, and a 1, but the 3 is the largest exponent. That's the key here. The largest exponent is a 3. How many zeros? 1, 2, 3. When I have 3 is the largest exponent, I could easily have 3 zeros. But it's not always the case. So you look at the equation here, and if you don't trust that that's the graph, it should look pretty close to that if you put that in your graphing calculator. Your largest exponent is 4. But the number of zeros is 1, 2. Since this valley, this minimum, never crosses the x-axis, I don't have any more solutions. I only have 2 solutions. So oftentimes those numbers will match, but they won't always match. The rule is, though, that the maximum number of zeros a function will have will always be equal to the largest exponent. So keep in mind, it says the maximum number of zeros a function will have. It doesn't say the number of zeros will always be equal. The maximum number of zeros. So this has a largest exponent of 4. The graph will never have more than 4 zeros. It might not have any. It might only have 1 or 2 or 3 or 4, but it will never have 5 or more. That's the general rule of thumb here. So on our next page, go ahead and take a second, press pause, and figure out what is the maximum number of zeros for numbers 1 and 2. That's right, for number 1, it's 5, because 5 is the largest exponent. And for number 2, it's definitely 3. It's not about what exponent comes first, it's not about adding your exponents, it's about the largest value, the largest number for your exponent. For the rest of today's notes, we're going to be using our graphing calculator. So now is when you absolutely have to have that graphing calculator out. And we can answer the first question without it because it's just asking, based on this equation, what's the maximum number of zeros that the function will have? I have an x squared, an x, and a constant. 2 is the largest exponent term. 2 is the maximum number of zeros. Part B is asking you to sketch the graph using your graphing calculator. So I'm not looking for perfection over here. What I'm looking for is a fairly accurate sketch of what that graph looks like. So open your graphing calculators up Alright, so now let's remember how to use our graphing calculators. In order to graph this, I have to press the y equals button. And to save time, I already have the equation typed in. If you need to press pause to type it in, go ahead and do that. But make sure your negative is outside the parentheses, your fraction is in parentheses, x is squared, plus 2x, plus I have another fraction, I'm going to put it in parentheses as well. Once your equation is in there, hit graph, and now we see a fairly accurate image of what we need. If yours doesn't look like mine, you need to press zoom and select 6 standard, or scroll down to 6, and that'll graph your function. At this point, we go back to our graph and we sketch it, but there's some key things that we have to have accurate. I have 2 zeros on my graph. One is a little left of my origin and one is somewhere towards the middle on the right side. As I go to my graph, I'm going to mark those because I need my graph to be fairly accurate. Doesn't have to be perfect. I also see that I have a vertex. It's a maximum and it's in quadrant 1. It's going to be halfway between my 2 zeros. So I'm going to go in here and I'm going to mark where that is. Once I have those marked, it's a curve, don't draw a V. There's a fairly accurate sketch of what this looks like. Based on this, we saw and we talked about, it's a peak, so that's a maximum point. And now, the other reason I had you put these 2 points, your zeros, and this point, your vertex, in here, is we're going to use our calculator to find the exact coordinates of those. The vertex is a little bit tricky, so make sure you follow through with every single step I'm going to talk about. Okay. This is going to be a calculation. We're going to calculate exactly where this point is, so every button I press is important. We want to calculate, that's above our trace. So we have to, and it's in blue, so we have to hit the second button. Second trace is going to give me my list of things that I can calculate, and if you look, I can calculate a maximum. I know that this is a maximum point, so I have to choose maximum. Whether I scroll down and press enter or hit 4, it's going to take me here. Now the calculator is going to ask me a series of questions. It's really important that we do not do what we do first semester and just hit enter 3 times. We have to follow through these steps. It's asking you for a maximum within a certain range. So think about our interval questions from our previous video. It needs its left bound. The maximum point is here, so it's just saying when it says left bound, hit enter when you're somewhere to the left of it. It's to the left of it already. Hit enter. Changed to right bound. Now it's saying hit enter when that's blinking to the right of the maximum. It's not. So I have to scroll to the right along that function until I get to the right of the maximum. How far right? It doesn't matter. I can stop here because I know it's to the right. Go somewhere where you know it's to the right, but don't overdo it. Hit enter the second time. When you look, you should have these vertical lines it's drawn in. As long as the point you're trying to find is in between those vertical lines or the arrows at the top, then you are in good shape. That means when it says guess, it's really just asking you to check, is the point you want inside here? It is, you hit enter. And it'll tell you the maximum. Now, these calculators, for some reason, they're programmed where they're not going to give you exact numbers. Round them to the nearest hundredth. But if you see something like this, 0.999999999, round that up to the whole number. So instead of 1.99, this is 2. So I'm going to go and I know that this ordered pair here is at 2, 4.5. And I can write that in here. It's the coordinates of my vertex, 2 and 4.5. Now, to find my zeros, it's going to be a little bit different. Here are my zeros. This is where my y is equal to 0. So what I'm going to do in my graph is, in my actual calculator, I'm going to type in y equals again. Keep my y1, but I'm going to go down to y2 and type in 0. because this is going to allow me to find my 0 and find the same way that we did during first semester. If I hit graph now, I can see I just actually graphed that axis. Now I'm able to do second, trace, 5, which is intersect. And here's the trick, there's 2 zeros, so you have to tell the calculator which one to find. Meaning you have to kind of scroll before you do enter, 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 close to it. Doesn't have to be on it, has to be close. Enter, enter, enter. Intersections at -1, 0. There's one of my solutions, or one of my zeros. And then pay close attention to the second one. When I do second trace 5, if I just hit enter, 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 it's going to give me the exact same answer, because it is lazy, and it's only going to go as close to the closest intersection point. So if I want my second intersection, I absolutely, before I hit enter at all, have to scroll as far to the right and as close to that intersection as I can to make sure I am telling the calculator where to go. I'm telling it what to find. Okay? So I went beyond it a little bit, quite a bit, and it's still going. So I can stop it, go back. And hit enter, enter, enter 3 times. So even there is good enough. And hit enter, enter, enter 3 times. And I'm at 5, 0 for my second solution. I want you guys to press pause. Well, in a minute, I guess. We'll talk real quick about these first couple questions, but what's the maximum number of zeros? Again, it's 2. Now, press pause, sketch the graph, tell me if it's a max or a min, find the coordinates of the vertex, and find all of the zeros. Unpause when you have all 4 of those things done. So your graph, your function should look like this. Make sure you put arrows on the end of it. Those are extremely important in all graphs. And you see that it has a minimum. Now, is mine perfect? By no means is that perfect. That's what I need to see, is just some accurate representation. If you have not tried to find the vertex, make sure you have the right function. Go back and find the vertex and the zeros. Alright, so I'm going to go through the vertex again. It's slightly different because now, remember, you have a minimum. So when you do second trace, you have to choose 3. You have to choose the minimum. And then again, it needs the left bound and right bound. So I go to my left bound, that means to the left of my minimum. Anywhere to the left is good, and hit enter. Then go to the right of the minimum. Anywhere to the right is good, and hit enter. So I'm going to do this purposely so it's not symmetric. And you'll see, just want to make sure we see our vertical lines too. There, my minimum is here, not right in the middle, but it's in between my 2 vertical lines. In between my arrows. Now when I guess, it's going to give me the correct vertex. And again, it's -1.00000002. That's -1. So my vertex is at -1, -4. And when you are graphing, make sure you put 0 in for y2. That way you can find your solutions or your zeros the same way we did first semester. Go ahead and do that now, please. Hopefully we found our solutions, our zeros, to be -3, 0 and 1, 0. Come to class prepared tomorrow. Make sure you have your graphing calculator. We are going to be practicing this quite a bit to make sure we are very clear on how and what buttons we press to find our zeros and to find our vertex.